Welcome back everyone. We're going to be looking at how to differentiate today. And once I give you this powerful tool, you will be able to differentiate any function that your heart desires. So what is this magical equation that tells us how to differentiate? Well, it's called first principles. And if you're familiar with algebra, you're probably already halfway there to actually understanding it, because the conceptual side is very similar. With linear algebra, we have 2 points on the line. The slope is equal to the difference in the y-coordinate over the difference in the x-coordinate. It's a similar sort of thing here, but of course we want to find the slope of the tangent at a given point, because on a polynomial, if we draw a tangent between 2 points there, that's not a good indication of what's happening to the slope. So how do we do this? Well, it's quite clever really, but we have these 2 points. They're just very, very close together. So close that the distance between them approaches 0. And that's where first principles comes in. So imagine these dots. Imagine I take this dot and I move it down and I move it so it's very close to here. Instead of having the slope being that dotted line there, my slope representation is now just from there to there. It's getting closer to what the actual slope is at this bottom point here. The closer I move that point towards each other, or the closer I move that top point towards the bottom point, the closer I get to the true value of the slope of the tangent. And that's what I'm doing. So let's have a look at the first principles equation. The f prime of x, which we know from our first video, just means the derivative of a function, the slope function of a function, equals the limit as h approaches 0, something I'll just touch up on in a second because that's probably new, of the f of x plus h, take the f of x, all divide by h. So, what we're simply doing is we're looking at these 2 points, and one of the points is going to be x, f of x. F of x is just like having y. It's just like having a point x, y. It's as simple as that. You're probably thinking, but what is this h? What does this h mean? Well, it's simple. H is just a very, very small distance. Imagine that we've zoomed this little section in quite large and we have the 2 points here. Well, h would just be the distance between them. And it makes sense, because we have x, which is the length up to that point, and then we have a little h added on. So, we have the f of x plus h. And x plus h is the other coordinate. So, what we're really doing is a neat little trick here. We're saying, if this h is going to approach 0, then these 2 points are going to pretty much lie on top of each other. And if these 2 points lie on top of each other, then it's like having 1 point there. The slope of the tangent at that 1 point. The points are almost merging, almost ready to collide. But you're probably thinking, wait a second, we've got a problem. And yes, we do. We cannot make h equals 0 in that equation, because if we're dividing by h, then we're going to get divide by 0. And something you're probably wondering is, well, how do we get this from the slope equation? Okay, I'll just take it back a little step, and we'll actually plug in these values. So we know we have x, which is some distance up to a point, and then we have a little bit more, which makes x plus h. Those are x1 and x2. And then we have y1 and y2. So let's say that y2 is the f of x plus h, because that's the point that's going to be further up. And let's say that the f of x is y1. That's how we get the top line. We get the bottom line by having x plus h, which is the equivalent of x2 from our linear algebra slope formula, and then we take x from it, which is the equivalent of x1 from our linear slope equation in algebra. And that's how we get the equation, because the x's cancel. X take x is equal to 0. So let's go ahead and solve this. I know you're just aching to actually differentiate, so we're going to differentiate a function of x squared plus 3. A nice simple one to begin with. So, what we simply do is we put in the f of x plus h. So if this is our f of x here, it's quite simple. Wherever there's an x, if we want the f of x plus h instead of the f of x, we just make any x term x plus h. Makes sense? So we have the f primed of x equals the limit as h approaches 0 for the for x plus h squared. Again, I'm just replacing that x with x plus h, plus 3 take x squared take 3. You're probably wondering, why is it take? Well, if that's plus and the operation there is take, we're going to have take and plus together, which is going to result in a negative overall. And all of that is going to be over h. From there, we can expand x plus h squared, so that it's x squared plus 2xh plus h squared. Again, you've probably expanded some brackets before. Boop. X squared, boop. X plus h, boop. X plus h, and boop. H squared. Hence we get x squared plus 2xh plus h squared. Take x squared, take 3 on h. Now at the moment you're probably thinking, this is a very long and tedious way to find derivatives. And that's true. That's why in the future episodes I'll actually show you shortcuts to doing it. So don't be discouraged. This is just how people many years ago did differentiation before they actually found all these patterns. But now, a little hint. Any term that doesn't have a h in it is going to actually cancel out. And there's a good reason for that, but I won't go into that just at the moment. But that means we have x squared, take x squared, cancelling out. Means that we have, whoops, I forgot plus 3 in there as well, but we have plus 3 and take 3 cancelling out. And so we end up with 2xh plus h squared on h. But we need to get rid of h in the denominator. And there's a simple way to do this. We just need to factor out h in the numerator. So, we put h out the front, and because of that, we just rewrite the expression without h in it. So we have 2x here, because that h is out the front, so it's no longer there, plus just h, because one of the h's from h squared has actually gone out the front again, over h. And this means that we can make h go to 0 now, because we can cancel them out. So now, we don't necessarily need the limit as h approaches 0 anymore. We're just left with 2x plus h. But of course, h went to 0. So we're just left with 2x. And 2x is the slope function that represents the slope at any given point on x squared plus 3. But that's just a function. We want to find the slope at a point, an actual point. Well, we can plug in any value of x we want there and get the slope at any point on there. I'm going to try something unique this time. I'm probably going to find the f prime of 5. In my last video I looked at 3 quite a lot, but this time I'm going to look at 5. So we go 2 lots of 5, and we get a slope of 10. The f prime of 5 for this function here is 10. So that's a reasonably steep slope. And that's how we use first principles. It's using that linear algebra concept, but making points that are so close to each other that this extra distance of h that is beyond the point is becoming very close to 0. So it's like just surveying the slope at one point. Thank you very much for watching, and in the next episode we'll be learning a bit more about what this limit thing actually means, and we'll be learning a bit more about how we can actually get this answer without having to go through this equation. I'll see you next time.